For the next two examples, we are going to find first a Maclaurin series and then a Taylor series generated by some functions. So the first one says find the Maclaurin series for the function f of x equals 7 times cosine of negative x. So first thing I'm going to do here, just like I did with the previous example, is I'm going to go through some of the derivatives. If f of x is equal to 7 times cosine negative x, then the first derivative obviously the 7 isn't going to change, but when we take the derivative of cosine, it's negative sine. So to be negative sine negative x, but then when you take the derivative of the negative x, we get another negative in there. So basically what you'd have is this. Negative 7 sine negative x times negative 1 is the chain rule. So you end up with positive 7 sine negative x. For the second derivative, when you take the derivative of 7 sine of negative x, you get 7 cosine negative x times negative 1, so that's negative 7 cosine negative x. And I'm going to continue for the third derivative. When I take the derivative of cosine, it's negative sine. So that would make this a positive, but then I have the negative here. So I end up with negative 7 sine negative x. And the fourth derivative is going to take us back to where we started from. So this is going to be a repeating thing. Now, it says find the Maclaurin series. So we have all these derivatives. So if you look back, let me scroll up here to that first page. So for the Maclaurin series, it's the Taylor series where the a value is 0. So it's going to be f of 0 plus f prime of 0 times x plus the second derivative evaluated at 0 over 2 factorial times x squared, and so on. So I'm going to go ahead and create a series based on that. So we've got, and actually let me switch to a different color here. So we have f of 0 plus f prime of 0 times x plus the second derivative evaluated at 0 over 2 factorial times x squared plus the third derivative evaluated at 0 over 3 factorial times x cubed plus the fourth derivative, once again evaluated at 0, this one over 4 factorial times x to the fourth, and it would keep continuing on. So what do we have? Well, if we plug in 0 into the original function, we'd have cosine of negative 0, which is just cosine of 0. Cosine of 0 is 1. 7 times 1 is 7. Now we look at the first derivative, which is sine, 7 sine negative x. So if we plug in a 0 for x, we're going to have sine of 0, which is 0. So we have 0 times x, that's just 0. So moving down the line here, second derivative, we're back to a cosine. So cosine of 0 is 1. Negative 7 times 1 is going to be a negative 7. And then 2 factorial, I'm just going to leave as 2 factorial for right now, times x squared. We get to the third derivative. We're back to a sine. Sine of 0 is 0. So we have a 0 here. It's going to zero out this entire term. And then moving down the line, the fourth derivative, we're back to cosine. Cosine of 0 is 1. 7 times 1 is 7. So we have 7 over 4 factorial times x to the fourth. And this would continue. And you could probably start to see that pattern developing. So I'm going to do two things at once here. Obviously, the zeros are gone, but I'm going to pull the 7s out. So that leaves me with 1 minus 1 over 2 factorial times x squared plus 1 over 4 factorial x to the fourth. And you can probably see how this would continue. Your next one would be minus 1 over 6 factorial x to the sixth plus 1 over 8 factorial x to the eighth. You can see that pattern continuing. Written out in our sigma notation, we could say it's 7. And then we're going to look at the series from n equals 0 to infinity. To account for it alternating between positive and negative, we're going to have negative 1 to the n. Then x will be to the 2n, because this would be the 0th term, first term, second term, over 2n quantity factorial. Now, we're going to do a second example here. This one is a Taylor series, and it says find the Taylor series generated by f of x equals x cubed minus 2x plus 4 at a equals 2. Now in this case, I'm going to do the same thing I did before. I'm going to look at some of these derivatives. But in this case, we're going to get to a point where the derivatives zero out. So f prime of x is going to equal 3x squared minus 2. The second derivative is just simply 6x. The third derivative is 6, and the fourth derivative onward is just going to be 0. So the way the Taylor series works, let me scroll back up to that very first page. Because you're multiplying the terms by these different derivatives, once we get to the fourth derivative onward, it zeroes out. So in this case, we're going to just be looking at 4 terms here for the series. And the way that's going to look, we're going to have f of 2 plus f prime of 2 times x minus 2 plus the second derivative of f at 2 over 2 factorial times x minus 2 squared plus the third derivative over 3 factorial times x minus 2 cubed. There's no use in writing any more out because, like I said, they're just going to go to 0. So when x is 2, we have 2 cubed minus 2 times 4 plus 4. So 2 cubed is 8. 2 times 2 is 4. So we have 8 minus 4 plus 4. So that's just 8. Now we're going to look at the first derivative, evaluate, evaluate. So sorry, I've got a sinus infection that's been lingering. First derivative evaluated at 2. We have 3 times 2 squared, so 3 times 4, which is 12. 12 minus 2 is 10. And that's times x minus 2. Now, we're going to look at the second derivative when x is 2, so that's going to give us 12. It's 12 over 2 factorial, and 2 factorial is just 2 times 1, so 12 divided by 2 gives us a 6 times x minus 2 squared. And then the last term here, we're looking at the third derivative. Evaluated at 2, it's still going to be 6. And it's going to be 6 over 3 factorial. 3 factorial is 3 times 2 times 1, so it's also 6. So we have 6 over 6, which is just 1, times x minus 2 cubed. So that's the Taylor series generated by that function.